Hello everybody. In this video we will discuss stereochemistry of the ring opening reaction of an epoxides. So in one of my previous video where we discussed how to make epoxide, I discussed the stereochemistry of the epoxide formation reactions. So maybe you can watch that video first to figure out how we can draw the product here with proper stereochemistry, but I will give the answers here. So the way you can you draw the product is first you draw these two carbon atoms, so which is I draw it out here, and then put the epoxide onto the top, and then you draw the wedge and the dash, the wedge and the dash. Okay, and now you just have to figure out. So if you remember, this one here is a double bond, right? So sp2 hybridized carbon atom, both of these are. So double bonds are planar in structure. So if something is planar, it's gonna look something like this. It's gonna look something like this. Now the epoxide can be formed on top of this planar structure or on the bottom of this planar. So both are possibles. Okay, so you could have a situations where the ethyl group here, so if you notice, both of the ethyl group are on the same side of the double bond, so which means I will draw both of the ethyl group on the wedge. Okay, and that leaves us my hydrogens on the dash, and my methyl group is on the dash. So methyl group and hydrogen were on the same side of the double bond, so I kept both of this on the same side. So dash means going back away from your plane of the paper that you're writing, so in this case the iPad. Okay, so in this case the ethyl group is coming towards you. You could have other situations. So remember I told you the epoxide can form on the top and also form on the bottom. You could draw the other version of the product where epoxide, so it's going to be enantiomers of this. So if you follow this systematic pattern, it will be a lot easier. Okay, so now I'm gonna write the ethyl group on the opposite side of the wedge. So opposite side of wedge would be dash. So I will write my ethyl group here and here. And that slips us my hydrogen and methyl group on our wedge. So you noticed whatever I am doing, I am keeping them on the same side of the plane. So in this case, both of these were on the wedges. In the previous one, both of these were on the dash. And here, both of these were on the same side of the double bond. So you notice all three are on the same side. Now, if you look at the ethyl group, it were on the same two sides of the double bond. Here, both of these are on the wedges. Here also, both of these are on the wedges. Again, for exams, like I would be perfectly fine if you don't draw this one out, okay? But just know that the other form also exists. Okay, so let's look at here. I will be using only one of the structures to show you the answers. So now we have a nucleophiles. Okay, so we have a nucleophile. CH3O- is our nucleophile. Now where it would attack. Okay, so let's remove this one a little bit below. Okay, so maybe let's just delete this one to clear our screen. Okay, so we have our CH3O-. Where it would attack, would it attack here or would it attack here? If you notice, this carbon atom is connected to 1, 2, 3 other carbon chains, right? But if you notice, this carbon atom on the left is connected to 1 and 2 carbon atoms. So obviously the carbon atom on the left is least crowded. Okay, so let's attack. So this is will attack on the least crowded carbon atom, attack on the least crowded carbon atoms. Okay, so this would push the bond here to break open. So now the bond will break open. Okay, now at this point, I want you to focus. Remember I told you before that the oxygen has to come from the opposite side. So the nucleophile here. So the nucleophile must come from the opposite side of the leaving group, which is in this case, the epoxide. So attack on the carbon atoms, and you should add this piece of information from the opposite side of the oxygen from epoxide. Okay, so if this was pointing to the top, this has to approach from the bottom. So let's draw the product. So how would you draw this reaction? Again, keep everything same. So here is how you're going to approach this. So you put O negative here, and you put OCH3 here. Okay, I will color code so that you will know. This is O minus CH3. So you see, I draw the O negative on the opposite side of the OCH3. And then once you are done, those two things. So this is how you shall solve this problem. So draw these structure like this, and then just add wedges and dashes. So I will add, I was trying to color code. So I will add a wedge here, and then a dash here. Then I will also add a wedge here. Then I will also add a dash here, and keep everything as it is. So if you notice, ethyl, ethyl, we was on the wedge before. So now they're still gonna be on the wedge. So ethyl is on the wedge, ethyl is on the wedge. Again, ethyl was wedge before, now they're still on the wedge. How about the dash? So you notice hydrogen is on the dash and methyl is on the dash. We're gonna keep them also on the dash and wedges. Okay, so that's the answer. So that's pretty much all about it, right? So you could have done the exact same thing for the previous, the enantiomers that we had of the structure. The other one I deleted. So you could draw the same thing as well. So you're gonna get another product. So enantiomers of the same things. So that will be plus enantiomers, right? So you're gonna get the another version of this one. So plus the enantiomers. Okay, so the final step of this reactions is all we're gonna do is we neutralize the O negative ions, right? And the stereochemistry is gonna stay exactly the same. So I will draw the same thing again. So you have OH to the top and OCH3 to the bottom, and then draw our dash and wedges. So wedge, dash, wedge, dash, and keep the group exact same way. Ethyl, both of the ethyl were on the wedges. Hydrogen and methyl were, both of them were on dash, and that's the answer. So that's how you do this very easily. Okay, so let's do one more problem, and then we can end this video. So what if we have something like this? So let's say we got our epoxide where, okay, there is a methyl group here. Okay, so what if we have this? What would be the answers here? So, and then we treat this one with, I will give CH3, CH2, MgBr. Okay, so this would react as if this is CH3, CH2 minus, MgBr plus. So in this case, this would come and attack on here. So this would be the attack on the least crowded carbon atom. Least crowded carbon atom from the opposite side of the oxygens. So this is important. From the opposite side of the oxygen of the epoxide. Okay, so the epoxide right now is on the wedge. So epoxide right now is on the wedge. What is the opposite side of the wedge? It would be dash. So let's draw the answers. Okay, so when the attack happens, the bond will obviously be broken. Okay, so let's draw the answers here. So opposite side of, so this is the bond that's breaking. This is the bond was to the top on the wedge. So this means the new incoming group has to be from the bottom. So it's going to be on the dash. Dash. Color coding so that you know what is the new bond we just made. CH2, CH3. So that's where it came from. And everything else is going to be as it is. So you noticed our wedge was O negative. And this was methyl was still to the dash. It is still on the dash, still going away from your plane. And this is on the O negative. And the last thing we will be doing here is gonna be neutralize it, H3O plus. So again, this is gonna be methyl. This is gonna be now O negative becomes OH. And here it becomes CH2, CH3. All right, so that's the answers. Now, if you notice, I did not draw a couple of things here. There is a hydrogens right here, okay? So if you know, there is a hydrogens right here, which is on the dash. Now, when this nucleophile is coming from the opposite of the wedge, which is dash, coming from the opposite side of the oxygen, this hydrogen will push up as well. So this is attacking here. And as a result, you will notice the hydrogen here will get pushed up because it's going to move up a little bit as the new incoming groups comes into play. So it's going to be hydrogens right there. So you don't need to show the hydrogen, but just know that there is a hydrogens right there. So we could do, I'll do one more problem and then we will end this. So what if this is like this? And then you treat with CH3O minus. Now in this case, you can pause the video and then draw the answers. Okay, so this would come from the opposite side of the oxygen. So opposite side of the oxygen from epoxide is, epoxide was on the dash. So it would be on the wedge. So the incoming group has to be on the wedge. So it's going to be OCH3. And our stuff is O negative. And this is still as it is. Okay, so everything stays as it is on this side, but the new incoming group OCH3 has to be on the wedge because the opposite side of dash is wedge. And then we just neutralize it, H3O plus. And when we neutralize it, nothing changes. Only thing that changes is our O negative becomes OH, and this becomes as it is. everything stays as it is. Okay, so you can do this type of problems with the proper stereochemistry. Again, always remember the nucleophiles comes from the opposite side of whichever direction oxygen is pointing. Okay, so same here, whichever direction the epoxide oxygen is pointing, the incoming nucleophile is always going to be on the opposite side of it. As long as you remember that part and draw everything else as it is, that was before and afters. Like before before is the same, before and after are same. The only difference is your incoming nucleophile is always going to be the opposite of the epoxide oxygens. That's it. Okay, we'll stop here.